This lesson goes along with Chapter 12 of the Modern Refrigeration book. And in this lesson we're going to discuss the servicing and installation of small hermetic systems, such as systems you would find perhaps in a domestic refrigerator, small commercial refrigerator, as well as some process cooling. We want you to walk away with the ideas about selecting the proper tools and instruments needed for installing these systems. We want you to be able to list the supplies needed on a typical installer service call, because it helps to make sure you have what you need before you leave the office. We want you to be able to service internal and external mechanisms, for example electrical components as well as compressors and condensers, using these proper tools and materials. And we want you to be able to locate areas causing noise and make the necessary adjustments to the systems. We also want you to understand trouble signals. In other words, we want you to be able to go on a preventative maintenance and be able to understand what you'll see if something's about to go wrong. We want you to be able to list the common external service operations. We want you to be able to start a stuck compressor. We want you to demonstrate the proper use of piercing valves, be able to check for restrictions in the system, and troubleshoot common refrigeration problems. We also want you to be able to use the proper methods and equipment for checking electrical systems of refrigerators and freezers, and we always want you to be able to follow the approved safety procedures. Now, this lesson is going to be divided into a number of smaller lessons. Please make sure you view them in order, or they're not going to make any sense when you put the whole picture together. So we want to start off our conversation with the equipment needed, the tools, and the supplies. But we also first need to talk about refrigerants. You're going to find R12 as the primary refrigerant used in domestic and refrigerators for most of the 20th century. In other words, you're still going to have a lot of equipment out there that R12 is in there. As of 1996, R12 was no longer manufactured. R134A is now the primary refrigerant used in domestic equipment. However, units with R12 will still be operational for years to come, and you will have to still repair these units. So, instruments you're going to need for refrigeration service work: you've got to have a pressure recorder, a temperature recorder, in other words, your gauges and thermometer. You'll have to have an off-on recorder, possibly a watt recorder, an electronic sound tracer, electronic leak detector, compound gauge, pressure gauge, and a voltmeter, ammeter, ohm meter, and a test light. In other words, a little light bulb that you could plug in. You should also have the following refrigerant tools: high vacuum pump, recovery recycling unit, service cylinders for R12, 22, 502, and 134A. You should have a purging line with a hand shut-off needle valve and a check valve. You should have a cap tube cleaner. You should have a capillary tube sizing kit. You should have a soldering and brazing torch. You should also have a hand vacuum cleaner. You should have gauge manifolds. You should have process tube adapters, and you should have bending springs. For wrenches, you should have a set of 3/8-inch drive sockets. You should have an adjustable open-end wrench. You should have a set of Allen set screw wrenches. You should have a refrigeration ratchet wrench, in other words, a service wrench. You should have a set of 15-degree open-end wrenches, a box-end wrench, T-wrench. You should have some pliers, a wire cutter, slim nose. You should have a hammer and a rubber mallet. You should have bending springs for 1/4-inch, 3/8-inch, and 1/2-inch outside diameter tubing. You should have a flaring tube. You should have a tubing cutter. You should have a pinch-off tube and a swagging tool. You should have some standard screwdrivers. Okay, in other words, 3, 6, and 8-inch screwdriver with insulated handles. Very important. You're working around electricity. You should have a Phillips screwdriver, 3, 6, and 8-inch with insulated handles. You should have wire solders, 60/40 and 95/5, as well as now you should have some silver solder. You should have soldering flux. You should have some alloy wire. You should have brazing flux. You should have steel wool. You should have some medium-grade sandpaper, plastic tape, and a refrigerant recovery unit. You should also have some disposable cylinders of refrigerant. You should have coils of soft copper tubing. You should have some copper pipe, cap tubing, filter dryer cartridges. You should have some refrigerant oil of 150 and 300 viscosity. You should have a refrigerant oil can that's a spout type can that you can get in closed openings. You should also have some cleaning cloths. You should have some relays, capacitors, some motor controls, refrigerant controls, overload protectors, light switches, sealing compounds, dryers, and filter dryers. You should have some sight glasses, flared fittings, piercing valves, and valve adapters, as well as valve cores. Now, all of these supplies is quite a lot, and it is a large investment that your company has made in making sure you have these supplies on hand, but they're really important as you start running service calls. We're going to start off with installation. Correct installation ensures proper operation of a refrigerator or freezer. Units are shipped with full written instructions. You want to make sure you carefully follow the directions on the crate as you uncrate the refrigerator or freezer. There are some areas of the cabinet that can be easily damaged in moving or uncrating. They include the bottom of the condensing unit, the back of the unit because the condenser may be in the walls and can be damaged. You can also damage the door by forcing it out of alignment or causing it to buckle. Compressor domes may be shipped with either removable shipping bolts or loosened dome shipping bolts. A hand truck can be used in moving the appliance. Be careful on what side of the unit you put the hand truck on. Make sure you look at the box. When you properly position a refrigerator or freezer, don't locate the refrigerator or freezer in direct sunlight or near an oven, warm air register, or other heat source. Remember, the room should be large enough to provide proper airflow to the coil of the condenser. Check the electrical rating on the appliance against the electrical supply provided at the wall outlet. There should be a separate circuit from the fuse or circuit breaker box to the refrigerator freezer outlet. Do not use an extension cord between the power cord and the wall outlet. The resulting voltage may be low. Voltage at the refrigerator outlet can be checked with a voltmeter or multimeter. If the voltage at the outlet drops more than 10 volts when starting, the wiring of the circuit is not heavy enough. A flicker in the lights at the moment of starting is a sign of a poor electrical supply. If the wall outlet has a 3-prong socket, the unit has a matching cord plug, there is grounding. If not, a wire must be attached between the metal part of the cabinet and a good ground such as a water pipe. Always check for proper grounding in the outlet box supplying current to the unit being serviced. Take a voltmeter reading from the live wall connection to the receptacle ground connection. A full voltage reading indicates that the outlet is properly grounded. In installations where there is inadequate space for air movement, cooling fans must be used. Units with a shroud covering the condenser must have air circulation at the bottom, back, and top. Units that have the outside shell as the condenser surface must at least have a 2-inch space around the surrounding cabinets and surfaces. A level should be used during installation to ensure correct leveling. Front supports on refrigerator and freezers are usually adjustable. Test the wall outlet with a voltmeter to determine the presence of electrical power before you start the equipment. Put the temperature control in the off position. Connect the electrical cord to the wall outlet. Test the unit for operation prior to moving it into position. Set the temperature control in the middle range. After a few hours of operation, check the thermometer in the refrigerator compartment. Adjust the temperature control as needed. If the unit does not start, check that the electrical circuit is in good condition. Next, check for mechanical trouble. Open and close the doors to make sure that the interior lights are functioning properly. If the refrigerator or freezer is using a cap tube system, refrigerant is stopped, then start it immediately. It may fail to operate. Disconnect the refrigerator for a few minutes. Allow the refrigerant pressure time to balance between the high and the low sides, and then start the system again. When you install an ice maker, you're going to find out that many domestic refrigerators have automatic ice makers. They're connected to a cold water line by a coil of a 1/4-inch copper or plastic tubing. Prior to putting the refrigerator into place, run the copper tubing to the nearest cold water line. Cabinet partitions or the floor may need to be drilled. Mount the tap valve on the water line. Connect the tubing to the valve. Connect the other end of the tubing to the water line fitting. Allow several large loops of tubing so the unit may be moved out for cleaning and servicing. Turn the tap valve stem in slowly to pierce the cold water pipe. Check for leaks. Gently move the unit back into place. Again, looking at the picture, note the coil of tubing. This is so that the unit can be pulled out and serviced. In Connecticut, you may not use the tap valves. You'll have to solder in a true on-off valve for you can't use piercing valves. When you shut down a refrigerator freezer for a period of time, you have to take precautions to prevent rusting and remove the odor. Remove the plug and switch off current. Defrost until the unit is completely defrosted. Remove water from the interior. Wash the insides of the cabinet with a solution of baking soda and water. Thoroughly dry the cabinet. Leave the doors or lids slightly ajar to allow circulation of air during the shutdown period. Federal law requires the removal of doors from any out-of-service refrigerator or freezer. Children can suffocate when hiding or playing in a discarded unit. When taking a refrigerator or freezer out of service, always remove the doors. There are a couple troubleshooting issues with hermetic refrigerator freezers. Potential complaints of unsatisfactory performance from customers are basically refrigerator does not run. It may be running all the time, temperatures too cold. Refrigerator runs all the time, temperatures are too warm. Refrigerator runs all the time, temperatures are satisfactory, and refrigerator cycles, but food compartment is too warm, and freezing compartment is okay. You have some additional ones. Refrigerator cycles, but freezing compartment is too cold. Motor control cuts out. Refrigerator cycles satisfactorily. Refrigeration is poor. Refrigerator cycles, but does not freeze ice cubes. Refrigeration cycles, but too much ice accumulates around the evaporator. Or the refrigerator mechanism is very noisy. So let's begin with the ice on the evaporator. Large ice buildup in food storage space is a result in poor cooling. The cause is usually a leaky door seal or gasket. In a frost-free or automatic defrost refrigerator, frost buildup indicates the defrost is not operating. Refrigerators with separate freezer compartment door often have an electric heater around the door. This is referred to as the Mullion heater. The Mullion heater prevents ice or moisture from forming around the door opening. Insert a thin piece of paper between the door and the cabinet. It should hold tightly when the door is closed. If it can be pulled out easily, the gasket needs to be replaced. Moisture and ice in the insulation indicates an air leak in the outer cabinet, seal, or shell. Wet insulation will lose its heat insulating qualities. Two indicators of moisture in the insulation are the condensing unit will run more often than normal, and the outside surface of the refrigerator will feel colder than normal whenever the insulation is wet. Most freezers provide a small opening through the inner lining connecting the insulated area with the inside of the freezer cabinet. Moisture will tend to escape through this opening and condense on the evaporator surface. Prior to servicing a refrigerator, you need to know the normal temperature in the evaporator during the operating cycle, the normal pressure on the low pressure side during the operating cycle, the normal temperature of the condenser during the operating cycle, and the normal pressure on the high pressure side during the operating cycle. A temperature recorder using vapor-filled bulbs may be used to test operating temperatures. A high-pressure gauge and compound gauge may be used to determine operating pressures. Noises in the refrigerator come from rattles, might be loose baffles or ducts, tubing touching something while vibrating, a tilting of the condensing unit caused by an uneven floor, fan and motor vibration, a loose evaporator unit door, loose articles on shelves, and shelves not seated properly on supports. An ultrasonic leak detector may be used to isolate many noises. Noise from within the unit may indicate it's laboring too hard. To determine this, test the electrical load with an ammeter or watt meter. 3 seconds is the average time to operate a relay on starting. A slower start indicates an overload. A vibration or hum can be reduced by carefully bending the tubing away from the contact or clamping rubber blocks onto the tubing. Be careful when bending the tubing so you don't kink it. Loose baffles or ducts can be secured with self-tapping sheet metal screws. Pressure-sensitive tapes provide protection against moisture, heat, sound, and electromagnetic waves. An inspection mirror is often needed to see into hard-to-reach places. Make sure that you don't touch the shaft of the inspection mirror across anything that's energized. The next problem was the cycling time for refrigerators and freezers. Cycling time for residential refrigerators and freezers depends on a number of factors, including the amount of storage space being used outside the box temperature and the compressor condition. Any unusual changes in tight cycling time should be investigated immediately. You want to check all performance data information prior to servicing a unit, usually located in the identification plate when mounted on the compressor. This information will include type of refrigerant, refrigerant charge, compressor horsepower, compressor, speed, running amps, voltage, phase, and also some additional items. This is an example of a chart showing operating conditions. You'll see lines on ambient temperature, the 3 columns, and then it will show you cycles per hour based on this temperature. You want to make sure all your performance data is within these numbers. Servicing of the hermetic refrigerators includes external servicing, internal servicing, or overhaul of the hermetic systems. External service operations can include cabinet hardware, ice cube maker, cleaning, and eliminating noises. External service operations may also include electrical in terms of power and circuit, thermostat problems, defrost thermostats, interior light, fan motor, damper controls, and motor compressor. You could also include defrost problems, defrost control and circuit, defrost heater and coil, cabinet heaters, evaporator fan and circuit, condenser fan and circuit, light circuit, butter conditioner circuit. External mechanisms, electrical wiring, and electrical parts can all be checked for operation quickly using a volt, amp, ohm meter, or multimeter. Some additional external troubles can be located by looking for ice on the evaporator, frost or sweat on the suction line, warm or hot discharge lines, ice or sweat on dryers, dirty condensers. Carefully check the following parts of the hermetic electrical circuit prior to replacing a compressor. Make sure you have power in the connections. Make sure the thermostat is good. Make sure the wire terminals are all clean and tight. Check the relays and check the capacitor if there is one. The external electrical components can be checked independently by removing them from the system. Another method is to temporarily replace the item with a test part of the right size. The unit may then be checked to see if it will run. Electrical connections must be clean and tight. If they are dirty, they may overheat. This high temperature will discolor the connection. A blue or greenish tint indicates overheating and corrosion. If the insulation is charred, overheating has occurred. A plug-in thermal motor protector protects the motor from overheating. In addition, a start relay positive temperature coefficient, PTCT, is used. Conditions such as open circuit and grounded electrical wires are easily checked with a meter. A test cord can be used to check 4-pole motors. 2-pole motors may be tested only by using a proper sized relay in the circuit. These motors overheat if the starting circuit is connected for more than 2 or 3 seconds. When you have an electrical problem on the hermetic units, check the electrical supply. Check the appliance voltage specifications. Use a voltmeter to test the open circuit voltage. Plug the appliance in. Check the voltage while it's running. The open circuit voltage is likely to be slightly higher, but no more than 5 volts with the motor running. A difference of 10 volts or more indicates serious problems, such as an overload, possible motor winding damage, or poor wiring to the wall outlet. Locate the wiring diagram on the system. Check each circuit independently. If the compressor fails to start, determine the electricity is reaching the motor of the compressor. If it is, check the starting relay and circuit protectors. Disconnect all wire from the motor compressor. Check the motor compressor with a manual start cord. The ground clip must be fastened to the dome. All clips or connectors should be plastic coated to protect from shocks. And this is an example of what you'll see. Press the manual switch. After 1 or 2 seconds, lift the switch button to open the starting winding circuit. If the motor operates, the problem is in the external circuit. Testing a capacitor start induction run motor can be done also. Use your test cord. Connect it into the proper locations. The capacitor is number 6. And then number 2 is run, number 3 is start, and number 1 is common. Replace the capacitor with a new one of the same voltage and microfarad reading. An extra clip wire or lead is needed. Operate the switch as in the previous frame. If the motor compressor works, check the electrical system up to the compressor. If the motor does not start, further the motor checks are needed. When you're testing a capacitor start induction run motor, make sure you short the testing capacitor using a 20,000 or 20K ohm 2-watt resistor. This will eliminate the possibility of electrical shock. Capacitors will hold the static charge until they're discharged. Test cords can be used for checking continuity and grounding by replacing the fuse with a light bulb. If trouble is found in the evaporator or condenser, they should be replaced. A defective Mullion heater may cause door gaskets to freeze to the circuit. Locate the circuit in the wiring diagram. Disconnect both ends of the Mullion heater. Test the heater for continuity with your ohm meter. If proven defective, check for another Mullion heater in the insulation. Test it. If it's operating properly, install it. If there's no additional heater, install a new one at the same wattage rating. If the problem is a faulty wire, use a stiff wire to pull the new wire through the insulation. You can also troubleshoot with circuit testers. The red in the system can be used to check electrical circuits on General Electric products. If it checks circuits for faults in the defrost system, thermostats, heater fans, and compressors. You'll have a male and female connector. It goes in line with your existing circuits. In multiple circuit contactor mounted at the front bottom of the cabinet is used. Always turn the thermostat to the off position prior to testing it. After connecting and testing, turn the power on. If the power on light should be lit. If not, the power circuit needs to be repaired. All Tecumseh motor compressor terminals are set up to read common start and run from left to right. Motor terminal connections may be stamped R, S, and C, and if they're not identified, measure the resistance of the compressor windings. First, measure the resistance across each set of terminals. The sum of the two readings should equal the third. So, the third, if you take the largest number, the pin across from that largest number is start, or is common. Okay, so you have R and S as 6 ohms, R and C is 2 ohms, C and S is 4 ohms. You notice the C and S and the C and R add up to the 6 ohms. The pin across from the 6 ohms is common. The next highest measurement from common to another pin is your start, and the remaining pin is run. Determine which terminal is common. The common terminal is the one that does not contain the greatest resistance. Determine which terminal is the start terminal. The start terminal should include the greatest resistance between itself and common. The last terminal is the run terminal. Mark the final motor terminal locations. You have 3 ways to start a stuck compressor. Disconnect the wiring to the motor's compressor. Connect a test cord into the electrical circuit of the main winding. Connect an extra capacitor into the circuit. Turn on the power from 1 to 3 seconds. The extra capacitor will try to reverse the compressor rotation. The capacitor cannot be left into the circuit more than a second or 2, or it will cause the motor to overheat. Connect the 120 volt motor compressor into a 240 volt power circuit and use a starter cord. Press the push button for only a second at a time to avoid motor damage. The extra voltage could break the stuck compressor loose. And another extra torque method is to connect a 240 volt 100 microfarad start capacitor across the terminals of the run capacitor. The connection must be for no more than 1 second. Short cycling is a term to describe the unit that starts and stops too frequently. This can be caused by the thermostat not being mounted securely, loose connections of start relays. But the caution, don't tap the relays to check it. This can cause the points to damage the motor. To clean the external mechanisms, the condenser and the compressor should be cleaned every 3 months. Units with condenser fans should be disconnected from the electrical power prior to cleaning. Clean the hermetic dome using a vacuum cleaner. In the shop, high pressure air, carbon dioxide, or nitrogen should be used for cleaning. Goggles should always be used, and there should be adequate ventilation when using gases to clean. Internal service includes any of the following: removal of any part of the hermetic system, determination of air in the system, discovery or lack of refrigerant, investigation for clogged filter dryer or cap tubes. Internal service operation require gauges and servicing devices. These devices include vacuum pumps, refrigerant cylinders, recovery machines, and any other part you'll need. Prior to opening the system, thoroughly clean all connections and valve fittings. Install a valve adapter or piercing valve. Install a gauge manifold. Install refrigerant recovery equipment. The most common internal service operations are locating and repairing refrigerant leaks, purging, charging, and recovery of refrigerant, cleaning or replacing the cap tube, replacing a compressor, replacing a filter dryer on the high side, installing a filter dryer on the low side, and evacuating the system. You could also need to add oil. You might have to use a vacuum pump. You might need to replace an evaporator or condenser. And some of these service operations are best performed in the shop. When you're diagnosing internal troubles, use gauges, thermometers, and electrical instruments, and careful observation. A partially frozen evaporator with another part of heavily frosted indicates lack of refrigerant. A sweating or frosted suction line indicates liquid refrigerant in the suction line. The cause may be a broken thermostat or too much refrigerant. Internal electrical troubles involved in the motor connections are very rare. Most internal problems are due to air and moisture in the motor compressor causing corrosion and eventually burnout. Liquid refrigerant reaching the compressor may remove oil or slug the compressors. Valves may be broken as the compressor attempts to pump oil or liquid refrigerants. Continuous running and no refrigerant and a condenser cooler than normal may indicate a restriction on the cap tube or filter dryer or screen on the high side. Moisture in a system will cause the unit to malfunction. Moisture will form ice in the refrigerant control at the point the liquid refrigerant is expanding into the evaporator. You'll have a system that will not completely defrost. Ice that caused the blockage will disappear. Unit will work again only until the ice forms again at the refrigerant control. Pressure will decrease in the suction line. Compound gauge shows a steady decrease over several hours. Pressure will suddenly become normal again. The cycle will keep repeating. Moisture in the system will also cause the unit to malfunction because it creates corrosion problems within the system. The refrigerant reacts with water molecules to form acids. The acids also increase corrosion. Moisture in the refrigerant may be removed by installing a dryer in the liquid line. The procedure is to install the manifold gauges, recover all the refrigerant, dry and clean the filter dryer components, apply flux, heat the connections, remove the old dryer, install the new dryer. Then you have to braze them all back together, test for leaks, evacuate the system, charge the system, warm the refrigerant cold enough to melt the ice, and the dryer will absorb the moisture as it circulates. There is always a small amount of wax in refrigeration oil. The oil circulates with the refrigerant. Sudden expansion at the refrigeration control, accompanied by low temperature and pressure, can cause some wax to separate from the oil. This wax collects on the refrigeration control. Over time, it may restrict flow or clog the control. A restriction can be checked with a piercing valve. You want to note the following: a pressure test showing low side pressure to be very low. Liquid refrigerant shows up in the condenser, and the unit does not produce any refrigerant at all. Always clean or replace a clogged valve or capillary tube. Pack the control with dry ice prior to removal to keep ice or wax locked in the faulty refrigerant control. A shortage of refrigerant usually indicates a leak in the system. Lack of refrigerant is indicated by low side pressure below normal, evaporator that is too warm, high side pressures that are below normal, and piercing valves mounted on the outlet of the condenser that when opened allows gas to escape. A gauge is used to service a hermetic system. There are several types: a block manifold or a standard manifold. A gauge manifold with 2 gauges, 2 hand valves, and 3 separate lengths of flexible tubing is useful for performing necessary operations. This is an example of a gauge set connected into a system. The hoses have 1/4-inch flare fittings that can be with synthetic rubber gaskets. Connections can be made to a pressure type with finger pressure alone. Manifold gauges can be used to produce a vacuum. So, as you continue through this lesson, the next step is you're going to want to finish your reading of Chapter 12. You want to participate in the discussion boards, and you want to answer the end of chapter questions. When you are all set and have everything turned in, ask your instructor and you'll be able to take the end of lesson quiz, and then you can move on to the next lesson.